Madagascar sits just 400 kilometers off the coast of Africa, separated from Mozambique by a narrow channel of the Indian Ocean. It's so close you can almost see the mainland on a clear day. So when you meet someone from Madagascar, you'd expect them to speak an African language, to share ancestry with East African peoples, to fit neatly into the story of Africa, but they don't. The people of Madagascar, the Malagasy, speak a language that has nothing to do with Africa. It's Austronesian, from the same family as Hawaiian, Maori, and Tagalog, but not just any Austronesian language. Malagasy is most closely related to Ma'anyan, a language spoken by a small group of people in the interior of Borneo, 7,000 kilometers away across the Indian Ocean. Not coastal Borneo, not a seafaring culture. Inland Borneo, where people live in longhouses along rivers, far from the sea. This makes no sense. How did a language from the jungles of Borneo end up on an island off the coast of Africa? And when geneticists finally analyzed Malagasy DNA in the 21st century, they found something even stranger. The Malagasy are roughly half Asian and half African, a genetic mix that exists nowhere else on Earth in quite this way. This is the Malagasy mystery, and for centuries it was considered, in the words of geographer Jared Diamond, the most astonishing fact of human geography. How did people from Southeast Asia reach Madagascar before Africans did, despite being 7,000 kilometers away? And why does their genetic and linguistic signature still dominate an island that sits within sight of Africa? This is a story that rewrites what we thought we knew about ancient seafaring, human migration, and the boundaries of the possible. The mystery begins with language because language was the first clue that something very strange had happened in Madagascar. When European explorers and linguists first studied Malagasy in the 18th and 19th centuries, they were baffled. The language sounded nothing like the Bantu languages spoken across East Africa. It had different grammar, different vocabulary, different phonology. And when linguists traced its origins, they found that Malagasy belonged to the Austronesian language family, a vast family that stretches from Madagascar in the west to Easter Island in the east, from Taiwan in the north to New Zealand in the south. But here's what's extraordinary. Within that massive language family, Malagasy isn't just generically Austronesian. It's specifically part of the Southeast Barito subgroup, spoken by a small cluster of ethnic groups in central Borneo. The closest living relative to Malagasy is Ma'anyan, with a lexical overlap of about 90%. If you take a Malagasy speaker and a Ma'anyan speaker and give them time to work through pronunciation differences, they can understand significant portions of each other's speech. This is like discovering that the people of Iceland speak a dialect of Basque. It doesn't make geographic sense. And the problem gets worse when you look at who the Ma'anyan people are. They're not sailors. They're river-dwelling agriculturalists who live in Borneo's interior, along the Barito River. They use boats for river transport, not ocean voyaging. They have no tradition of long-distance maritime exploration. They're about as far from being master navigators as you can get. So how did their language cross the Indian Ocean? For over a century, this was an unsolvable puzzle. Some scholars suggested that maybe there was an ancient seafaring Bornean culture that has since disappeared, that the Ma'anyan language was once spoken by a coastal group who later migrated inland. Others proposed that the linguistic connection was a coincidence, that maybe Austronesian languages were once more widespread across the Indian Ocean, and Madagascar just happened to preserve one. But none of these theories had evidence. They were guesses, attempts to make sense of data that refused to fit any logical model. The breakthrough came in the 21st century when geneticists started analyzing Malagasy DNA, and what they found was even stranger than the linguistics suggested. In the 2000s and 2010s, multiple genome-wide studies examined the ancestry of Malagasy people from across the island. The results were shocking and consistent. The Malagasy are approximately 50% Asian and 50% African in ancestry, but it's not a random mix. The Asian component traces back specifically to populations in Borneo and the broader Malay archipelago. The African component traces back to Bantu-speaking populations in East Africa, particularly Mozambique, Tanzania, and the Swahili coast. So far, this confirms what the linguistics suggested. The Malagasy are descended from people who came from both Southeast Asia and East Africa. But here's the twist that solves the mystery. When geneticists looked more closely at the Asian ancestry, they found it wasn't pure Ma'anyan. It was Banjar. Banjar people are a mixed population from southern Borneo, descended from indigenous Dayak groups, including the Ma'anyan, and Malay traders who came to Borneo centuries ago. The Malays were the key. The Malays, based in what is now Malaysia and Indonesia, were the elite sailors of the Indian Ocean, master navigators who dominated maritime trade routes from Africa to China. So here's what happened. Malay traders moving through Borneo encountered Dayak groups including the Maanyan. Trade, intermarriage, and cultural exchange created the Banjar people, a hybrid population that spoke a Malay-influenced version of Dayak languages and adopted Malay maritime culture. When some of these Banjar people, or groups closely related to them, migrated across the Indian Ocean, they carried the Maanyan-related language with them, but they also carried the seafaring skills of the Malays. This explains both the language and the voyage. The language came from inland Borneo, but the people who carried it had acquired the navigation skills needed to cross oceans. It's a case of cultural transmission. The Maanyan language didn't travel on Maanyan boats. It traveled on Malay-style outriggers, carried by people who spoke it as a substrate language even as they adopted Malay maritime culture. And this, finally, makes sense. You don't need the Maanyan to have been sailors. You just need their language to have been adopted by people who were. But the scale of what they did is staggering. The voyage from Southeast Asia to Madagascar is roughly 7,000 kilometers across open ocean. There are no stepping stone islands. If you leave the coast of Sumatra or Java and sail west, you cross the entire Indian Ocean with no place to stop until you reach the Maldives, Sri Lanka, or the coast of Africa. This isn't island hopping like the Polynesians did in the Pacific, where you can see the next island from the last. This is blue water sailing, navigation by stars, currents, and wind, with no margin for error. If you get lost, you die. And yet, they succeeded. How? Technology and knowledge. The Austronesians developed the outrigger canoe, one of the most seaworthy vessels ever invented. Outriggers are fast, stable, and capable of handling rough seas. They can tack into the wind, a crucial ability for long-distance voyaging. And the Austronesians were expert navigators. They used star paths, memorized sequences of stars that rise and set at specific points on the horizon to maintain course. They read ocean swells, wave patterns that indicate distant land or changes in current. They studied bird behavior, knowing that certain seabirds fly out to sea but return to land before nightfall, providing directional clues. But even with all this knowledge, the Indian Ocean crossing was extraordinarily dangerous. The most likely route was seasonal, using the monsoon winds that reverse direction twice a year. During the southwest monsoon, from May to September, winds blow from Africa toward Asia. During the northeast monsoon, from November to March, winds blow from Asia toward Africa. A voyage from Southeast Asia to Madagascar would have required careful timing, leaving during the northeast monsoon and riding the winds west. But there's a problem. You can't sail directly from Borneo to Madagascar. You'd likely miss it and end up in open ocean. The most plausible route involves following the monsoon winds, perhaps landing in Somalia, Kenya, or Tanzania, and then coasting south to Madagascar. Or, alternatively, sailing to India first, trading and resupplying, and then crossing from India to East Africa before heading to Madagascar. Either way, the journey would have taken months, possibly years, with multiple stops. And the fact that it happened at all, probably between 500 and 1000 AD based on linguistic and archaeological evidence, is a testament to human audacity and skill. But the Austronesian settlers who reached Madagascar weren't alone for long. Within a few centuries, perhaps even at the same time, people from East Africa began arriving as well, and their arrival transformed the island genetically, culturally, and linguistically. Genome-wide studies show that roughly 50% of Malagasy ancestry comes from Bantu-speaking East African populations. The closest genetic matches are to modern populations in Mozambique, Tanzania, and the Swahili coast. These weren't hunter-gatherers or isolated tribes. They were part of the Bantu expansion, one of the largest and most consequential migrations in African history. The Bantu peoples originated in West Africa and began spreading east and south around 3,000 years ago, bringing with them farming, ironworking, and new languages. By the time they reached the East African coast, they were experienced agriculturalists, pastoralists, and traders, integrated into the Swahili trading networks that connected Africa to the Indian Ocean world. When they reached Madagascar, they brought cattle, crops, and iron tools, and they didn't just visit. They settled, intermarried, and became part of the island's population. But here's where the genetics tell a very specific story, one that reveals exactly how this mixing happened. When you analyze Malagasy DNA, you see a striking pattern. Mitochondrial DNA, inherited from mothers, is predominantly Asian. Y chromosome DNA, inherited from fathers, is predominantly African. This is called sex-biased admixture, and it tells you which sex contributed more to which lineage. The pattern suggests that the initial Asian settlers included women, and they had children with African men who arrived later, or that Asian women were integrated into African majority communities through marriage. Meanwhile, African men, arriving in larger numbers or with greater social power, contributed heavily to the paternal lineages. But the language stayed Asian. Why? because in most societies, children learn language from their mothers. If the maternal lineage remained Asian dominant in the early generations, even as African men arrived, the language would persist. This is exactly what we see. Malagasy, the language, remained Austronesian despite heavy African genetic contribution. And this suggests something important. The Austronesian settlers weren't conquered or replaced. They were integrated. The society that emerged was genuinely hybrid, a fusion where both ancestries contributed, but linguistic and certain cultural elements remained tied to the Austronesian maternal lineage. This pattern, sex-biased admixture with language retention through the maternal line, is rare but not unique. We see it in other contact zones like the Garifuna of Central America or certain Creole populations in the Caribbean. But Madagascar is one of the clearest examples, and it tells us something crucial about how human societies blend. It's not always through conquest or replacement. Sometimes it's through integration, trade, and intermarriage, where both groups contribute genetically, but cultural dominance is determined by social structures like matrilineal versus patrilineal systems. And in Madagascar, the Austronesian language and certain cultural practices persisted because they were tied to maternal lineages that remained influential even as the population became genetically African dominant in certain regions. But here's where the story gets more complicated, and I want you to think carefully about this because it touches on how we define indigeneity and identity. Today, Madagascar has multiple ethnic groups and they don't all have the same genetic makeup. The highland populations like the Marina show about 70% Asian ancestry and 30% African. The coastal populations like the Vezo and Sakalava show the opposite, about 70% African ancestry and 30% Asian. Yet all of them speak Malagasy, an Austronesian language. So here's the question. Are the coastal Malagasy less indigenous to Madagascar because they have more African ancestry? Or does speaking Malagasy and being part of Malagasy culture make them equally indigenous, regardless of genetics? This isn't just an academic question, it has political implications. In Madagascar, highland groups like the Marina historically held more political power. And there have been tensions with coastal groups who are sometimes stereotyped as more African, less authentically Malagasy. But genetically, all Malagasy are mixed. It's just the ratio that differs by region, and the fact that they all speak the same language and share cultural practices suggests that genetics doesn't determine belonging. But let me push this further. If a group with 70% African ancestry speaks an Asian language and lives on an island off Africa, are they African, Asian, or something else entirely? I genuinely want to know what you think. Does genetic ancestry determine identity, or is identity determined by language, culture, and self-identification? Because if we say the Marina are more authentically Malagasy because they have more Asian ancestry, we're implying that genetics defines legitimacy. But if we say all Malagasy are equally indigenous because they share language and culture, we're saying genetics is irrelevant to identity. Both positions have implications. One risks essentialism, tying identity to blood. The other risks ignoring history and the very real ways genetics shape populations. Where do you stand? Leave your answer in the comments, because this is a conversation happening right now in anthropology, genetics, and politics, and there's no easy answer. And there's one more group that complicates this even further, the Maikia. The Maikia are a small population in southwestern Madagascar who until recently lived as hunter-gatherers in the forest, using bows, foraging, and avoiding agriculture. For decades, anthropologists debated their origins. Were they descendants of an ancient pre-Austronesian population that lived on Madagascar before anyone else arrived? Were they the original inhabitants, pushed into the forest by later settlers? It fit a romantic narrative, the lost indigenous people, preserving a way of life from before history. But in 2008, geneticists tested Maikia DNA. The result was definitive. The Maikia are genetically identical to their agricultural neighbors. They're not an ancient relic population. They're people who, for social or economic reasons, adopted a hunter-gatherer lifestyle within the last few hundred years. This is cultural reversion, not genetic isolation, and it's a powerful reminder that culture can change faster than DNA. The Maikia chose to live differently, and outsiders assumed that meant they were different people. They weren't. They were Malagasy who hunted instead of farmed. But genetics doesn't just reveal history. It also reveals evolution in action. And in Madagascar, natural selection has left one of the clearest signatures ever documented in human populations. Malaria is endemic in Madagascar, and it's deadly. Plasmodium falciparum, the most dangerous malaria parasite, is widespread on the island. But there's a genetic variant that provides near total protection against one of the ways malaria invades red blood cells. It's called the Duffy null allele, a mutation that removes a protein from the surface of red blood cells that malaria uses as an entry point. If you're Duffy null, you're essentially immune to Plasmodium vivax malaria, and you have some protection against falciparum. This allele is nearly universal in sub-Saharan Africa, where it evolved over thousands of years in response to malaria pressure. But when the Austronesian settlers arrived in Madagascar, they didn't carry it. They were vulnerable, and malaria killed them in large numbers. But over the centuries, as Austronesians and Africans mixed, the Duffy null allele spread into the Asian-descended populations. Today, even highland Malagasy with 70% Asian ancestry carry the Duffy null allele at high frequencies. This is natural selection, visible in real time. The African variant spread because it saved lives, and it spread so effectively that geneticists consider it one of the strongest selection signals in recent human evolution. Madagascar's environment shaped its people genetically, and it did so within just a few dozen generations. But humans also shaped the environment. When people first arrived in Madagascar, the island was home to unique megafauna, elephant birds, giant tortoises, and pygmy hippos. Within a few centuries, they were extinct. Humans hunted them, cleared forests for agriculture, and introduced cattle and goats that transformed the landscape. Madagascar's rainforests, once covering much of the island, were reduced to fragments. The extinction of Madagascar's megafauna is one of the most recent and best documented cases of human-driven extinction, and it happened in the time span we're discussing. Between 500 and 1500 AD, the Malagasy didn't just arrive and settle. They transformed the island, and the island transformed them in return. This is the full story: migration, mixing, selection, and environmental change all happening faster than almost anywhere else on Earth. So what is Madagascar? It's African by location, Asian by language, Indian Ocean by genetics, and Malagasy by identity. It's proof that humans were moving across oceans, mixing and creating new populations long before European colonialism, long before the age of exploration, long before anyone was drawing maps. The Malagasy are not an accident. They're not an anomaly. They're evidence of human ingenuity, the kind that builds boats capable of crossing oceans, navigates by stars across thousands of kilometers of open water, and creates new societies when different peoples meet. Madagascar isn't a mystery anymore. It's a synthesis. And if you think about it, that's what all of us are. Mixtures of migrations, selections, and adaptations shaped by the places we live and the people we meet. The Malagasy just did it in one of the most dramatic ways imaginable. If you found this story fascinating, share it with anyone curious about the hidden histories genetics is revealing. Have you ever discovered something unexpected in your ancestry? Do you think genetic ancestry should define identity, or is culture and language more important? Leave your thoughts in the comments. The Malagasy crossed an ocean no one expected them to cross, mixed in ways no one predicted, and created a society that defies every easy category. Their story is still being written in the genes of every Malagasy person alive today. I'll see you in the next video. Thanks for watching.